Hello guys, welcome to this tutorial. I'm going to show you how to deploy a microservices application in ECS. My name is Nginx and I'm a DevOps engineer. In this video, I'm going to show us first of all the application architecture. Secondly, we're going to see how we can deploy this application on our cloud. So we're going to explore the cloud infrastructure application architecture rather. We're going to see the Terraform code. We're going to deploy the application together and see how the application has been deployed. For the architecture, this is the user here who happens to access the application via the Nginx server, which serves here as a reverse proxy. Based on the route, initially, when the user accesses the application, it routes him directly to this microservice built around Angular, called the client. The user now can make a choice on the based on the articles that have been displayed on this application, which will therefore reroute either through the API or web API. The API is built around a Node.js application and has access to MongoDB. Now, for the Books API, it is built around Java that interacts with MySQL database. So we are going to build our infrastructure that will host this application. Now, as far as the infrastructure architecture is concerned, we first of all have two repositories, one for the infrastructure, the other for the application. So the infrastructure repository is managed by the cloud engineer, which he will build and push his Terraform code into this repository. The Terraform code contains the infrastructure resources that are to be deployed. Here we can see we have ECR, we have ECS, we have ALB, and the IAM roles. Now, when we apply the Terraform, we see it will deploy now the different services that we want. Now, when the very first time that it is deployed, it is configured to pick the pre-pushed images to ECR, which will run the different services. As you can see, this is the application that has been deployed here. But in this our case, they are going to be running on Docker containers. So we're going to see how all of those are built. So now, provided the developer has some updates that he brings in as far as his application is concerned, he pushes it to the app repository. GitHub Actions is triggered to build the changes and push to ECR. Now, what happens is that since we have 4 services, GitHub Actions is configured to be smart enough to detect where the change is coming from. If it is from Nginx, it's going to build only the Nginx container. If it is from Angular, only Angular, and so on and so forth. So GitHub Actions now will carry the different builds, run the security test and checks and make sure that the container is safe and pushes it to ECR. When it is pushed to ECR, GitHub Actions will equally run a new task definition revision that will pick the new image and then update the service that has been changed. Key performance metrics are copied. They are picked from the service, from the infrastructure, and based on them, we have to give notifications to the developer to understand basically what is happening with his code. Now, for the infrastructure code, we have the repo one, which has the Terraform, and the repo that has the application, which now we are going to look at it. So initially, the first we have the e-commerce infrastructure, that the name there that specifies that is the infrastructure. It is basically our Terraform code. Now, we see here, as far as the structure is concerned, we have our main, our outputs, the provider, the Terraform, TF reverse, that those are variables to be passed through during long time, and we have our variables.tf. And now we have a folder called modules, and it's inside this module that we are going to keep the different modules. So for the provider, it's AWS, and now for the main, we see We are configuring our Terraform to have store its the state in our S3 backend. This is the bucket name that is going to be created before this deployment. The key, that is where the Terraform state file is going to be stored. So it's going to be stored under the folder ECS, subfolder deployment, and Terraform state. For the region, we're going to deploy it in USS1, and it's going to use S3 state lock. Now we are going to deploy a module called network. The network is obviously supposed to carry basically our VPC and security groups. For the IAM, is going to deploy the different roles that are necessary to execute our our infrastructure. Now, for our ECS module, is going to deploy our ECS with the 4 different services. Here we pass in the different, these are the different variables that we have to pass in for it to work perfectly. And finally, we have the database. For a brief flow for our ECS, here we have we're going to be using our private namespaces. The namespaces is simply to be run inside. Is a private namespace that is going to permit us to make our applications to communicate within themselves without necessarily using their IP addresses, because since they are ephemeral, there's no need trying to follow up their IP addresses. So it's simply we just create a service discovery and then give it a name. Like here, we're going to use API. So this for the container that works, that is handling the API request, is going to be called API. So each time we want our application to access this container, we are just simply going to access it through this API, exactly as DNS works. We're going to do the same for clients. We're going to do the same for Nginx and web API. Now, for the ECS cluster, we're going to create the resource ECS cluster. For CloudWatch log groups, we have to create log groups so that we can monitor the behavior of our application, so as to notice all the failures that are coming in, maybe container logs and so on, so as to be sure that everything is working as planned. So all the 4 containers are going to be having their log groups. Now, for data sources, we had to keep sensitive data in our system manager parameter store. So we have to store Mongo URI, we have to store the DB pass. Now, we need, for Nginx, we need a load balancer, as we saw it in the architecture. So we're going to create first the target group. These are its parameters. We're going to create the load balancer and reference the target group. We have to create a listener, and that is it for the load balancer. It's when we are going to run the Nginx service that we are going to reference the load balancer. So for the task definitions, we need obviously 4 task definitions for the 4 different microservices. So first we have the client. Now this, I'm just going to comment about this. For the network mode, we need AWS VPS for it to be able to use the DNS that we set up earlier, that's the private DNS. These are the configurations. So for more information about deploying task definitions, we can investigate on our documentations, as official documentations for Terraform task definitions. So here we have clients, the necessary field that we have to pass for it to be able to be considered as a task definition. And as you can see, we need the information about the container that is to be run, the protocol, which is TCP, the app protocol, which is HTTP. Now, we have task definition for the 4 different tasks, and each of them we have to pass the environment variables. Here, for instance, we need environment for the MySQL host, the user, the database. All of those, they are environment variables that we have to pass onto it. And now for the secrets, for the sensitive data, we have to keep them in our parameter store. So this is how we can pass environment and secrets in Terraform. Now, for Nginx, we do the same. Now, as far as the services are concerned, that definitions have to be declared and then referenced inside our services. So the first service, we have the client here. We have to reference the task definition that was created above. That is it, that has been done here. For the next results, we have the API, we have to reference it. We have to give it the service discovery, that is going to this is the name that is going to have. Web API, we have to do the same. And then for Nginx, we need a load balancer, which will be listening for 80 over the internet. So I am now the AWS caller identity, make it as data is going to take the identity of the current user, which in this our case will be the IAM role that we will build through the OpenID Connect. We are going to create an IAM policy here, and below we are going to attach it. Here is an IAM role, that's the execution role for our task definitions. They are going to assume it and then run them. This is another IAM role for the different tasks. Here we are trying to attach an execution policy. This is the execution role, and we're going to attach it to attach that policy to it. Okay, that is for IAM. The network is more of a VPC. This is the VPC that we have created: the internet gateway, the public subnets, the private subnets, 3 public subnets, 2 private subnets for the database. For the availability zones, is going to our subnets. Our private subnet is going to scan through our availability zones and get the available availability zones, and then input it as the availability zone for our private subnets. For the route table, we have to create a route table and associate security groups. These are security groups for the elastic load balancer. As far as RDS is concerned, we're going to deploy a basic RDS. That is, this is we're going to be using a module that is stored already. That is the module link. We have our version 5.02 identifier books. That's a basic 20 gigabytes MySQL database that we're going to deploy. Here are the parameters that we're passing in. Owner is a user, then environment is there. So when all of that is set, before we deploy it, let's verify that our S3 backend has been created. That's this CF templates. Yes, this one. So we go to S3. Open tab. While that is opening, let me show us here the IAM role. Well, this one I created it through CloudFormation. In another video, I'll probably show us how to deploy or to create an OIDC provider role for our GitHub Actions. But in this our case, let me show you the class relationship. So what basically this IAM role does is that it is going to allow actions only from this repository. Yes, GitHub Actions can only execute actions only from this repository. Any other repository, it will fail. It's going to permit us not to either expose our keys. So you see here, I have to attach now 2 policies to it: deploy to ECR, to ECS, and push to ECR. Because what GitHub does is it pushes to ECS, it deploys to ECS, and then pushes to ECR. So I made all those 2 and made it to you see ECS create service, describe cluster, update service. Another action, ECS describe task definition, register. So these are the policies that are necessary for it to be able to deploy to ECS. Either create new task definition, trigger a new deployment, and stuff like that. Now for pushing to ECR, these are the policies that are needed. and we have happened to really do fine-grained permissions so that the user can only do what it has been configured to do. Now that was it. We are going to look at our S3 bucket. I'm sure it should be open by now. This is CF templates, all of that is one. That is what was in our, this is it. So it was earlier, it was created earlier on. You see, this is ECS. We're supposed to now see deployment. And after deployment, we're supposed to see our state file, the Terraform state. So that is it for our S3 backend. Now, if you can see our Elastic Container Service, first of all, let us see that nothing is on. Here we see there are no clusters for the Elastic Container. We had to create clients, Java API, Nginx, and Node API repositories. These are repositories that needs to be created. You could still create it through Terraform code, but it's easy, but we can still use it this way. After creating, we copy the URI and come to our variables. Terraform.tf var, you see API image. Where we have API, we have to paste it here, and then we have to choose the image tag, which here I choose latest, so it will always pick the latest version and deploy it. So these are the URIs of the different repositories. Now the project name, that's the project name that we give, so that our service, each of our services that are created, we are supposed to see this service attached to it wherever the name was given as this. For our region, we are working in US East 1. Our database name is books. Our username is emat. So now let us look here. We have our repositories created. Before now, I have pushed some containers up to it. Let us see. Yeah, we see the latest is one container is pushed there for all of them. That's the size. Now for databases, let's verify that no database has been created. Zero database. So now we are going to apply now in Terraform and go and see how our services are deployed and see them one after the other. So the first thing is we run Terraform init. This will download all the dependencies that will permit Terraform to interact with our infrastructure or our AWS account. So it's going to initialize the backend, make sure everything is all right. So Terraform init has been successfully executed. Let's see. It's going to give us a rundown of the resources that are going to be created. We have to look through them and be sure that that is what we want to create before we do our apply. So Terraform plan is going to take some time because the infrastructure is having so many resources. So I pause the video and try to finish the Terraform plan and successfully had a dry run of all the different services that are going to be created. You see yeah, you see roundtable, security group. So these are all the resources that are going to be created. It's huge. The services are too much. Not time for us to waste seeing all the different services. So we have to read through and make sure we are happy with them. I'm going to see the summary below. That will give us the number of services, resources that are going to be created. The plan we have to add 51. 0 to change, 0 to destroy, because nothing has been destroyed. Now, this outputs, the DB host, the ECS cluster name, the VPC ID, these are all outputs of our main, that's under our root the output under the root. So output.tf, which is optional. We have the VPC ID. See here, we have the VPC ID that will be outputted. We have the ECS cluster name. That's the VPC, the ECS cluster name that is going to be outputted, and so on. So if we want to display even the DNS name of the load balancer, we can make it as an output here actually. So since we are happy about that, I'm going to say apply. I can see icon photo. Oh, it will not ask me if I want to type yes. So it is now going to apply the file changes. Apply complete. We have 51 resources added, 0 change, 0 destroyed. As for the output, we see the DB host. It gives us the DB host, ECS cluster name, and the VPC ID. So if we go to the VPC, we see a new VPC with this ID that has been created. If you move up, we're going to see all the different services that have been created. So now it's time for us to go to the console and verify all the services that have been created, and even see ECS cluster and the load balancer to see how they are working. Now we are at the database. Let's refresh and see our database. We see the size, the DB T4G micro that has been created. And yeah, this is the VPC under which it has been created. So that is good for our database. Next, let's first of all see the clusters. Let's refresh. This we see ECS Microservices deployment cluster is having 4 services that are running. 3 is already running and 0 is pending. Let's go and check and see what is happening. Probably we signed it so early. Okay, the last one, which is Nginx, is still deploying. This is the last one actually to be created. We still have to give it some time for it to finish deploying the last task. After some time of waiting, we see that all the services are running and they are complete. They have all picked the different services. You see here is the API service. This is the client. This is Nginx. This is web API. If we want to see the logs, container logs, and go inside and look at the logs, you see it's running, everything is fine. This is the container running. It says it is connected to the database. The server is running on port 5000. Everything is running as planned. Now, what I did not show is the parameter store. I'm going to look at the parameters that we have. You see, we have the database password. We have the normal URI. Right. The database password is installed there for security reasons, and for the Mongo URI, what happens is that we have to create a Mongo. We have to go to an external service on MongoDB Atlas and create a MongoDB, and use its the URL to access the MongoDB. So for now, I created a free MongoDB alias. So I created the database cluster. The name is Epoch, and if I want to connect to it, I can take through drivers. You see, I'm using Matrix Node.js, so it's going to give me this MongoDB URL that I'm going to use from any application to connect to it. So before doing that, you see here it's showing my DB passport. So when we create the MongoDB cluster, it's going to ask us for username and password. So we have our username and password. We have to put down the password in here, and then here we're going to pass in our MongoDB database name. So we're going to add, since our own is Epoch, we're going to put Epoch. So we're going to copy this and save it now inside our parameter store. Like here, let me open our MongoDB URI. So let me show let me show you this. This is MongoDB plus the server. So my database password was Nginx, and then the database name was the Epoch. So we need to pass this URL for our container to be able to connect to it. But obviously, since this one is having my password, that's the reason why I had to store it as a secret in my parameter store. So now coming back to our EC2, I have to go down to my load balancer. I'm going to see the application load balancer that has been configured. There we go. This is the DNS name. I'll copy it here, and then I'll paste it in the browser. And there we go. Yeah, it's already showing me a welcome message, meaning that it has been connected. It has connected to our database. This is our boutique. This is our shop. We are therefore very sure that our database, our EC2, the ECS cluster, everything is working the way we wanted it to work. So basically, this has been the deployment of our database. Now, that was the first run that the cloud engineer has to run. So we have now to see the